Cool. Sean is he's got big boots to fill. So I've got big boots to fill. It's tough to go after him. That was an amazing presentation. Hopefully I can catch the one tomorrow at 3, I think. So my name is Kevin Neilson. I'm with Developer Relations for Moonbeam. And today I want to start by giving you an update in terms of what we've been working on in the past year, what's new with Moonbeam, and then I want to show you how you can connect AI and Moonbeam. So I don't know if anybody, raise your hand if this is your first ETH Denver. Nice. Welcome. Great to have you here. Second ETH Denver. Anybody? Cool. Third? Fourth? Nice. Sick. Anybody fifth? Okay, cool. Nice. So welcome to everybody. Hope you enjoy it. And there's a lot going on this week. The thing that I just wanted to encourage you, if you're on the fence about submitting a hackathon project, a lot of people, their first ETH Denver, they think, I don't know if I can submit a project. I don't know if mine's going to be good enough. I'm not really sure. Maybe I'll wait a little bit. No, just go ahead and submit it. There are so many different prizes. You can find a niche project to submit a prize to, and more than likely you'll walk away with something. And what we've also noticed, at least historically, which is not awesome, is that the trend for a number of projects has kind of trended down, it seems like, the last couple of years. And that could be just due to there's so many different side events. People go to lots of parties, or they get, pulled in many different directions. So if you can cut out some time to submit a project, I think you could do really well. Okay, so back to the main event. Again, I'm going to talk a little bit about Moonbeam, and then we're going to talk about how we can connect AI and Moonbeam. So I also work with a project called Cluster AI, and Cluster AI builds AI tools for developers. And it offers models, and it offers a bunch of different tools, and that's the API that we'll be using today. So you guys may have heard of Moonbeam. If not, I will do the briefest of introductions and reminders to what Moonbeam is. So Moonbeam is an Ethereum-compatible smart contract platform on Polkadot. We are a Polkadot parachain. We launched in 2022, and in 2021 we launched Moonriver, which is the Kusama parachain. So that launched first. But when we brought Ethereum compatibility to Polkadot, we didn't just say, "Here's your EVM. All right, have a nice day. This is it. Let's stop here." But rather, we wanted to incorporate all as many of the features as we could that we thought our users could benefit from that Polkadot has to offer. And that includes things like governance, on-chain treasury, XCM, and a lot more. So part of it is integrating palettes, right? So if you go to Polkadot.js apps and you look for, you connect to Moonbeam, and then you look for the XCM palette, right? Or you look for the governance palette, or you look for parachain staking, right? We've customized our own. In the case of parachain staking, that's kind of a special case. But we've got these palettes, but we can't just say, "Hey, you need to access all of this through Substrate." We wanted to make sure that EVM developers can access these palettes as well. And so for most of the palettes that we offer, like parachain staking, like ones for cross-chain transfers, we have Solidity interfaces, which we call precompiles. And this allows a developer to call these functions, from a web application, or they could have a smart contract interact with these precompiles. And so that's kind of where I'm getting at when I say like EVM plus. So Moonbeam has 6-second block times. We'll get back to this a little bit later. Used to be 12 seconds. And Moonbeam, of course, relies on the Polkadot relay chain for finality. And when we're building EVM compatibility, there's a module called Frontier, which maps and emulates kind of Ethereum calls and makes it such that you can drop this into your own Polkadot parachain. But if you were to just take the Frontier palette and kind of stop there, there's still a lot that developers would be expecting in order to get kind of a seamless experience. And so one of these is a fully Ethereum compatible Web3 RPC. And what I mean by this is you have RPC calls like ETH get balance, or get transaction by hash, or get block by hash, anything like that. You can call those directly as you would to an Ethereum node. You don't need to make any changes for Moonbeam. And so what this means is it's very easy for somebody who's got an application that's built on Ethereum. It's easy for them to point it over to Moonbeam and not have to make all these back-end changes, to their web application. Okay, and one more important component is Polkadot uses a different type of account structure. Ethereum uses H160 addresses. Polkadot uses, I think SS58 is the name, or a variation of that. And this has different length, different private key, different structure, and they are not compatible with each other, right? So if you wanted to just provide Ethereum compatibility and you wanted to also have your Polkadot account, you need to maintain two different types of accounts. And so from the very early days, we set up a unified account structure. So you just use one Ethereum account and you access both the Substrate API and the Ethereum API. So you don't need to juggle two different sets of private keys. You just have your normal existing Ethereum, MetaMask wallet, ledger, whatever you have. So Moonbeam's been around for a little while. And in 2024, we made some tokenomics tweaks to ensure, the longevity and the health of the network. Now, most of this is unchanged, right? Moonbeam has an annual inflation of about 5%, and this has not changed since Genesis. But kind of like a DJ, at a turntable, you see the DJ is like turning all these knobs and stuff. Like the music still sounds pretty similar, but like the knobs, there's some adjustments that are going on. So also unchanged, half of the inflation goes to stakers who delegate to Moonbeam collators. So this number is also pretty close to this one where I say 1% goes to collators. And these numbers can kind of get a little bit mixed up because if you are a collator, you might stake to yourself, right? And so you're getting some of the inflation as you're running a node, and then you're also getting some as a staker. So you're kind of getting some from both. But then we also have this value right here, which is 1.5%. And that is the parachain bond reserve. So when the network started, 1.5% of this was reserved for allocations to the parachain bond reserve. And you used to have to go through it and get like a crowd loan. Now you just have to purchase core time. And as folks may have noticed, when parachain auctions first started, Moonbeam was the second parachain auction winner, but I believe it was the largest in terms of like total DOT that you had to stake. And it was like many, many millions of dollars of DOT. And this value, has come down a lot. So it's way cheaper, way more accessible for you to purchase core time. And this is a great thing, right? Early on, there are dynamics of who wants to be first. And, maybe there's like a lot of hype at the beginning and stuff like that. But it's important that it's accessible for people who want to launch their own blockchain. So with that, right, there are a couple changes. The Moonbeam network no longer needs to have this huge parachain bond reserve, for some rainy day in order to pay for core time if core time is not actually all that expensive. So 80% of this 1.5% figure is going to the on-chain treasury, and 20% is still going to this parachain bond reserve. To purchase core time and kind of be a rainy day fund for core time. I also want to talk briefly about transaction fees and inflation and where that is going. This is only a proposed change. It hasn't gone through yet, but the idea here is right now, Moonbeam burns 80% of transaction fees, and then 20% go to this on-chain treasury. But as I just mentioned, the on-chain treasury is going to get filled up from the parachain bond reserve, so it's not as important to have this fee mechanism funneling it into the treasury. And so the proposal is to make 100% of fees actually be burned. And it hasn't yet been confirmed, but this is something that should go through pretty soon. Okay, and another thing to point out, reduce gas costs. Moonbeam now has dropped its fees from 125 gwei down to 31 and a quarter. So divided by 4. And these numbers are very small. We don't need to worry about the exact numbers, but I just did this as a quick test to say, let's transfer some native token. Let's also do a quick swap. Let's see what it costs. This will fluctuate, of course, a little bit with like network conditions and the type of transaction that you're doing. If you're doing something way more complicated, you will pay a little bit more. But yeah, we're not really worried about these small amounts. Now there's another UI improvement, which is a pretty major change, and it's important for users. Who just connect to the Moonbeam network through MetaMask or through whatever their wallet of choice is. And the way this snappy client works is previously, wallets such as MetaMask or Talisman, whatever your preferred wallet is, they were considering, they were waiting until a block got included and it got finalized by the Polkadot relay chain. And on average, this would take, at minimum 12 seconds, but, by the time you submit it, maybe 16, 20 seconds, something like that. And so if you're, trying to make an approval and then you're trying to make a swap, the user experience there is submit the transaction, wait 16, 20 seconds. Okay, now it's confirmed. Now let me do my next transaction. Okay, I need to wait another 20 seconds. And it's okay, right? That's not ideal though. We want it to be better. We want users to have a more seamless experience. So with this Snappy client, there are no changes to finality. So finality still comes from the Polkadot relay chain. It still takes the same amount of time. There are no changes there. All this does is say to the wallet, consider a transaction as being confirmed as soon as this block is imported, meaning as soon as whoever the RPC client is, they don't have to wait for the Polkadot relay chain to say that a block is included. They can just say, oh yes, we've seen this block. Everything checks out on my end. It looks good here. I'm going to consider this confirmed. And so I did a little comparison, right? I said, okay, let me try with this snappy mode versus the old way, and let me see how dramatic a difference is. Because if you just try it out, you'll definitely notice it. But sometimes it helps to quantify, and let's see exactly how it's doing. So with this quick little comparison, on average, when you ran it in snappy mode, your transactions were going through about 17 to 19 seconds faster. And this is when you click confirm, and you're just going to have a much better experience. So I just want to qualify here that, again, finality is not changed. We're not saying that, the transactions are getting finalized faster. And if you're submitting a huge amount of money or an incredibly valuable transaction, you're still going to want to wait for the Polkadot relay chain to provide finality. And Moonbeam has a custom API where you can check for finality. Moonbeam has deterministic finality, so you don't need to wait, like Bitcoin, you don't need to wait like 6 blocks or a certain amount of time before you can say something is pretty good and just about finalized. Instead, you can just query Moonbeam's custom API, and it will tell you yes or no, this is finalized or not. And again, that takes anywhere from 1 to 2 blocks for this block or transaction to be considered finalized. And you can query a block, you can query a hash, and yeah. And again, no action is required by the user. So as long as the user has in their MetaMask, they're using an up-to-date RPC provider. We've already convinced like all of our RPC providers to switch over to this new snappy mode. If you are running your own node, this is a change that you'd probably want to make. You just need to run your node with a flag that's experimental block import strategy. Kind of a misleading name. Experimental sounds like it's really risky or something like that. But this is something that has been tested for a while. Okay, so I also wanted to talk a little bit about synchronous versus asynchronous backing, what this means for Moonbeam, and kind of how Moonbeam has evolved and improved and grown thanks to the changes that Polkadot has made in the last year. So synchronous backing is the idea that when Polkadot is assembling blocks, it's going to focus on assembling the block sequentially one at a time, and it's not going to do any sort of parallelization in production of blocks. It's going to produce a block, it's going to have the backing stage, and it's going to propagate that block, get it out to the network, and it's going to get all of this done before it's going to work on the next block. And so it's much better to visualize it. And so if we were, this is going to be block production for synchronous backing. And we've got about a 12-second period right here, kind of split in two. And you can see this first purple part is the execution that parachains have in order to assemble their transactions and put them in a block. Now that's actually pretty small, right? Half a second, that's not a huge amount of time. So the majority of block production, 11.5 seconds, is stuff that's not assembling a transaction into a block and processing state transitions. So what's going on when we're processing state transitions? That's a smart contract call. That's transferring funds. That's transferring an ERC20 token. That's processing a cross-chain transfer through XCM. All the important kind of stuff that's going on within Moonbeam's EVM, that's only going to take place during this half a second of execution time. But Polkadot's introduced asynchronous backing, which is way, way better for many reasons. So there are a couple of reasons. So one is that rather than allowing parachains to produce blocks every 12 seconds, this allows them to produce blocks every 6 seconds. So Moonbeam's block time has gone down. That's fantastic. That's awesome, in and of itself. But because of this, there's another change that has occurred in parallel, and that's that the parachains have quadrupled the possible amount of execution time that they have. So they can have up to 2 seconds rather than that half a second of execution time. So if we were to look at a graph, up here we've got the first synchronous backing, and then we've got the comparison to asynchronous backing. So we've got a lot more time to produce and assemble a block. We've got 2 seconds of execution time. And while the backing phase is still occurring on this first block, we are already getting to work on producing the next block after that. So thus, asynchronous backing. If we were to consider, what that means for Moonbeam, it means that we've gone from 12 seconds to 6 second block times. That's great. So that in and of itself, you've got twice as much capacity for transactions. So that's cool. But as I mentioned, it gets better than that, right? It's not just a half a second of execution time. We've now got up to 2 seconds. Now, there is one limitation to consider, which is that the proof of validity, the size that can be, remains the same. And so what this means is if you're doing an incredibly complicated transaction, which takes up a ton of storage space on the chain, or is just incredibly computationally difficult, then you might still kind of run into a limit where, okay, your limit is not this execution time. It doesn't take that long to execute, but it's rather this POV limit that you're running into. And Moonbeam manages this based on its calculation of weight and gas costs. So this is not something that the smart contract developer has to really manage on their own. This is something that Moonbeam will kind of guide you along. You'll know if you are running up into these POV limits. So just a couple stats, and then we're ready to move on to the demo. And that would be, okay, the amount of time, milliseconds, right? 500 milliseconds. Now we've got 2,000, but we've still got a couple more changes that have taken place. So the block gas limit has gone from 15 million to 60 million. The single transaction limit has gone from 13.5 to 54 million. And what this means is in a block, it can take up to 60 million gas. But for a single transaction, it can only be 54 million. Okay, so I want to show a quick demo. And briefly, I wanted to introduce the demo and just kind of talk through some project ideas. So originally, I wanted to show a demo of using AI to rebalance smart contract pools, meaning StelSwap is the largest DEX on Moonbeam. And I had the idea that, okay, we're going to have this AI analyze the context of the pools, right? Which ones are getting kind of out of balance, which ones, have way more USDC and not enough DOT, or vice versa. And they're two kind of interesting approaches there. One is that there are already tons of, bots that do this regularly. We don't really need to create a bot to do this, but it would be fun to do. And it would be fun to feed into an AI and say, here are the composition of the pools, and, which one should we rebalance, which one needs the most attention. But there are kind of a couple things in cramming this into a demo. Is it needs to be on a production network, and there's also a lot of configuration in terms of contract addresses and pools, and a lot of parts to hook up. So the demo that I've got is something that's quite a bit simpler, but I just want to show you how you can use AI and connect it into a smart contract. And hopefully, this might, show you how you could do this on your own. And maybe you want to build something that's more complicated, that's like this auto rebalancing pool that uses AI. And I'm sure there are other, ones that you might want to build too. So I mentioned earlier Cluster. Cluster builds AI tools for developers. Cluster has tons of different models, including DeepSeek is one that it offers. It offers 3 different kinds of meta models. And it's not just offering these models, but it's offering them in a cost-effective way. So if you want to run your query in real time, you're going to pay X. If you say, hey, I've got all these API queries that I want to run, and you can run them anytime in the next hour or 2 hours, then you're going to pay less. And Cluster can help you, manage all of this. And you can get a free API key, and they start out with like $100 or $10 or something. So, which is like a gazillion, queries. So with our simple smart contract, we're going to ask Cluster for a quote of the day. And then we're going to store this piece of data on chain. And it's going to be stored in a smart contract where we can go and look at it, or we could have another contract query it. So I have on my GitHub here. So my GitHub name is the Mac Expert. So if you go to github.com/the Mac Expert, yes, this is old and a very old name. Unfortunately, you can't change your GitHub username without a huge amount of pain. It will mess up all your repos, and you'll never be able to make a clean commit ever again. So my name is locked in stone on there. Anyway, I've got 3 files here that I want to show you. And the first one is just a simple smart contract, which has an owner, and the owner is going to be, we're going to deploy it in Remix, and then we're going to go and have a simple script that's going to call the Cluster API. So all we're doing here, when we deploy the contract, whoever deploys it, they're going to be the owner. We have a modifier to make sure that only the owner is the person who can call the update data or call transfer ownership. But update data is going to make it larger. Yeah, thank you. Appreciate it. Thank you, Luca. There we go. Okay, really only one function that is important, and that's the update data one. So we're going to give our script, we're going to give it the same private key as the owner, and we're going to allow it to update what's stored in the contract. So I'm going to go to Remix, and I've got a demo that I've set up, but we're going to start, with the new file, and we're going to deploy it and go through. We're going to do this in real time. So let's copy the contents of our contract, and I encourage you to, follow along if you'd like. We'll call it, we'll just call it Moonbeam. That should be fine. And let's compile it. If you don't have any Moonbeam tokens, you can go to faucet.moonbeam.network, and that dispenses Moonbeam tokens for free on the testnet. Okay, so we've compiled it, and I want to go ahead and deploy it. And I mentioned that you want to make sure that the owner account is the same one that you're going to be giving to the script. So let's see. Let's refresh the page. Okay, so I mentioned that we just called it Moonbeam, so let's find that. Let's compile it. And as always, we want to make sure that we're testing in the right place. So you always want to switch to injected provider MetaMask, and 1287, that's the chain ID for the Moonbase Alpha testnet. Remix VM, that's fine for testing some EVM things, but it's not going to have any of the substrate specific things like precompiles or other things that are unique to Moonbeam. So generally, you always want to test either on Moonbase Alpha, or you can run your own local Moonbeam node and connect to that as well. So let's go ahead and deploy this. And we'll get back a contract. That was quick. I was talking about the snappy mode. So I should be on running the snappy mode myself. So if I click latest data, there's nothing there yet. We haven't stored anything yet, but that's going to be updated by our script in just a second. So we're going to make a note of the contract address, but I also wanted to show you what we're going to be doing. And so this is the Solidity smart contract that we have. We also have a update.js script, and I'll just kind of quickly walk you through what we're going to do here. So we've got a couple environment variables. We've got a private key. We've got a cluster API key. The private key, again, you want that to match the one that's deployed the contract in Remix. So for cluster, it's very easy to get an API key. So if you just go to cluster.ai, you can go to start building. You can create an account. You can get an API key. It's really fast. It's really easy. I'll also point you to our doc site here. If you go to list supported models, these are the models that are currently supported by Cluster. So try to zoom in a little bit so it's easier to see. DeepSeek is one. I mentioned MetaLlama. Importantly, the whole model name here, you see it starts with Cluster AI. This one starts with DeepSeek. You just want to make sure that you're copying the entire model name because you'll need to provide this as a parameter in the script here. So the base URL is api.cluster.ai/v1. This is the same style as if you're querying the OpenAI API. Cluster is compatible with the OpenAI spec. So all of the different types of queries that you'd make to OpenAI formatted, very, very similarly for Cluster. So we're going to give it a prompt, right? And for this simple example, we're just asking it for a quote of the day. And we're asking it, give me a valuable message, an inspirational quote, but please just give the quote because these models can tend to drone on a little bit and they can give you lots of advice and sometimes summarize the quote and do all sorts of funny stuff. We just want to have a, simple quote and we want to store that on chain. I mentioned we needed to provide the name of the model. So it's Cluster AI. I chose this one, the MetaLlama one. That's fine. You can choose a different one. We have a user prompt that we're providing, and we're also providing two more parameters here, a max tokens value. This is kind of a hard limit to the response that you'd like to get. So this is even like more strict, than tweaking the prompt, saying, please give me only the quote and no other commentary. If you just, chop the tokens at 10, it's just going to, cut off the response right there. It could cut off like in the middle of a sentence. There's also a temperature value. So temperature value is kind of referring to how different or surprising the response that you would get. So with a minimum temperature value, like the absolute lowest, you're going to get the same response just about every single time. So that might give us the same valuable advice every single time. And it would be the most generic, predictable, expected quote, that you can imagine. Maybe some vague thing about success or something that kind of fits an LLM's idea of what is an inspirational quote or what's a piece of valuable advice. But we don't want, the boring, bland advice. We want something that's a little more interesting, a little more surprising, and a little bit more, interesting. So we've tweaked up our temperature value. So the temperature value here of 0.9, the default is something like 0.5 or 0.6 is kind of, if you didn't provide this value, what you would get. In this API query, we also need to provide an authorization, and that is the cluster API key. And we also have a bearer here that we're indicating. Similarly, if you were doing like a curl command, you do the same thing where you'd say bearer and then provide the cluster API key. And then what the script is going to do is it's going to update our smart contract. And in the smart contract, there was also an event, I believe, that was emitted when this occurs. The event's not really important. But this could be valuable if you were indexing the smart contract, for example. Okay, so we're just about ready to run the script. So a couple things that we need to do. We need to insert the contract address. So let's do that. Let's go back to Remix. And I'm going to copy the address of the smart contract where we've just deployed. And again, latest data, there's nothing there so far. So this is a fresh, brand new script. So let's insert this contract address here. We'll save it. I've also got, I'm not going to pull up the .env right now, but in my .env, I've got the private key for the account. I've also got the cluster API key, and defined out just like that. Moonbeam testnet RPC. That's not important because we've already deployed our contract in Remix. But if you wanted to deploy through Hardhat, you would need to have that environment variable defined. So all we've done in the .env is we've defined these values here. Very easy. And, just be aware, don't commit this stuff to GitHub so that you can save yourself some time and hassle. Okay, everything looks pretty good here. I think we're almost just about ready to run it. What I need to do is I need to go to the directory where we have it. And that would be this one. How is the text size? I think it's okay. Yeah, I think it's okay. Called it Moonbeam AI. Okay, let's go ahead and run update.js. Okay, and we fetched some data from the cluster AI. Our quote is, you can't control everything. What you can control is how you respond to things you can't control. Okay, great. This is some inspiration, and it's not the totally generic one. This kind of reflects a higher temperature value, so that looks good and everything. But let's go and check on chain and see if this actually got updated. Okay, and it did. I can zoom in here a little bit too, but you can see here the string that we got back, and we can run it again, and it would update, as well. So it's a very simple example, right? But I just wanted to show you how you can connect AI and how you can connect a smart contract. And yeah, if anybody else has any ideas they want to share or about, how you might incorporate AI into a smart contract, yeah, I'd love to talk more with you about that. And I also have a couple minutes for questions. And I also wanted to mention that Moonbeam is going to be at the Polkadot booth, so booth 101. The Polkadot team always does an amazing job of snagging the best booth space. So 101 sounds like a great booth. I'm pretty sure it's very well located. We're going to be there 2 to 6 p.m. tomorrow and Friday, and also all day on Saturday. So find us there, come talk to us, and that would be amazing. And thank you so much to Zoe, and thank you everybody for organizing this. And it's really fun to be back here. I think we were in the same one last year, and there was a party up here, and it was sick, and it was super fun. So I'm glad to be back here. And if anybody has any questions, I can pass around this green thing. Cool. You can find me later too if anybody wants to talk off camera. Thank you so much.